Here we've been presented with C₃H₅, and that's said to be the empirical formula, and we've been asked to work out what the molecular formula is. And we've been told that for the molecule in general, like the actual molar mass is going to be 410 grams per mole. So how am I going to go about finding what the molecular formula is? Well, we've been given the molar mass of the molecular formula, but we don't at this stage have the molar mass of the empirical formula. I would want to determine the molar mass of the empirical formula, as I could then compare that with the molar mass of the molecular formula and figure out, well, what's the actual difference, if there is one, and scale up as appropriate. Before I proceed, one of the things to remember is, okay, well, what is an empirical formula? What is a molecular formula, right? So in the case of the empirical formula, that's effectively the simplest, or some would say the smallest, whole number ratio between the atoms of each of the elements present in the compound. And so in this case, as we see here, it's C₃H₅. Now the molecular formula is the actual number of each atom of each element present in the given compound or given molecule. Sometimes the empirical and molecular formula are the same thing in reality, right? So let's say a molecule's got like C₃H₅, right? Methane. The empirical formula would be the same as the molecular formula, right? But anyway, let's go ahead with this question. So the first thing I'm going to do is I'm going to try and work out the molar mass of the C₃H₅, and I'm going to do that. I'm going to refer to the periodic table to get the molar masses, and effectively here the periodic table will tell us, well, what the relative atomic masses of the relevant elements are. So hydrogen and carbon, and you can see we've got the relative atomic masses, which in this case is basically, well, it is what the molar masses are for those elements. And so we can simply say that the molar mass, so Mr for carbon, right, is equal to 12.0, and we can say that the Mr for hydrogen is equal to 1.0, right? So using these values, we can now work out the molar mass of C₃H₅. Of course, these are common elements, carbon and hydrogen, very common. So you probably already knew what the relative atomic masses of those are, but just for the sake of actually showing the reasoning process and kind of documenting that in writing, it can be valuable to still have this written down. Okay, so this, in order to calculate that, you know the coefficients. So we've got C3 and we've got H₅, right? So in the case of the C3, we're going to do 12, which is for carbon, so 12 times 3, and then in the case of H₅, it's going to be the 1, right? So plus 1 times 5. So feel free to have a go and see what you get when you do calculate that, right? And what you should get is 41, right? And what this effectively tells us is that the molar mass of our empirical formula is equal to 41, right? Well, gram. I'm going to add the units as well. So 41 grams per mole, right? Okay. Now, at this stage, we have the molar mass of our empirical formula. We have the molar mass of our molecular formula, and based on visual inspection, I think you can probably infer what the multiplier is. But I'm nonetheless going to go through the steps. So the multiplier. This is effectively what's the difference? What do we need to do to the empirical formula to get to the molecular formula, right? Is equal. It's going to be equal to the molar mass of the molecular formula divided by the molar mass of the empirical formula. Right? And if we do work that out, we're going to get 410 divided by 41, right? And I think, as I said, based on visual inspection, you can kind of work out what that is. But if you do need to use a calculator, which you probably don't, you get 10, right? So our multiplier in this case is 10. And what does that mean? What's the bearing on that for the figuring out what the molecular formula is? Well, we use this multiplier and we multiply the coefficients attributed to each of the elements, you know, by the multiplier. So let's go through that process. So carbon, effectively carbon, we're going to have so C₃H₅, right? So it's going to be 3 times 10, which is going to give us 30, and therefore we can say that's going to be C30. In the case of hydrogen, similarly, we're going to have H5, right? So we're going to have 5 times 10, which is going to give us 50, right? And that's going to give so that's going to be H50, okay? Now, when we consolidate these two values, what do we get? Well, in effect, when we consolidate them, we're going to get C30, C30 H50, okay? So this, in this particular case, is our molecular formula. And I'm going to go into an example of, well, because there is an important molecule that has this molecular formula that actually is, this molecule is present on human skin, and so, you know, let's take a look at that. So this is squalene, okay? There's two versions here. It's just these are isomers of each other. So one of them has some cis, like is a bit mixed between like some cis and trans kind of bonds, but this one is all trans squalene. So all the bonds are like, you might, if you look into it, you might find like it says E, right? So, but long story short, the process by which it's produced within humans, for example, tends to overwhelmingly produce this version, so the trans squalene. You can look into some of the reasons behind that. It's to do with the enzyme that produces it, and yeah, so this is produced in sebum. It contains about sebum contains about 12% of it is squalene, basically. And for those of you who study biology, like you would actually come across some of the organelles which actually are relevant to the production of squalene, right? So you may come across endoplasmic reticulum, right? So endoplasmic reticulum is actually the site where the squalene is produced. That's where the enzyme that produces it, I believe it's called squalene synthase. But yeah, it's produced in the effectively that's the site where it's produced, the endoplasmic reticulum. But yeah, I mean, so as we said, this would be, in this case, the molecular formula, right? C30H50.